Hi everybody, today in this video you're going to be looking at how to solve word problems that involve a linear system. In this course there are several different kinds of word problems that you'll be faced with, and we're going to look at two of them today. The first one that we're going to look at I usually call a rate versus rate kind of problem. The second type that we're going to look at today I call a value number type of problem. So we're going to jump right in, and I'm going to bring up an example here. I took right from the textbook from page 27, number 9, and it's talking about renting a hall, and there's two possibilities. Okay, so there's Pin Hall and there's Bloom Place, and this is a rate versus rate problem. How can we tell? Well, there's a rate of $15 per meal at the one place, $18 per meal at the second place. That's always one clue that this is a rate versus rate problem. And the rate versus rate problem will almost always be set up in the traditional kinds of ways. You'll see two equations, and they'll both be in the form y equals mx plus b. Right? In both cases, you'll see some kind of fixed starting something or a starting point. In this case, it's a starting cost, right, of $500 and a $350. And in both cases, there'll be a rate, right, $15 per meal and $18 per meal. Now, that's nice, but we generally don't use y's and x's if we are going to be doing a word problem. What we like to do is we like to define our variables and use letters that make sense, right? So we have to declare our variables, that's otherwise known as let statements. So instead of x and y, we're going to have two different variables, okay? So these are both functions, of course, so they're the relationship between two different things. What are the relationship between? Well, the charge, right, the cost, and the number of guests, right? So I guess our two let statements then have to talk about those two variables. So we're going to have something about number of guests. So let's let G be the number of guests. And the other thing that we're going to be dealing with is, of course, the cost. And I'm always picky. Whenever you're talking about some kind of number, you have to be very, very explicit about what are the units as well. And since it's cost, it makes sense then to let C be the cost in dollars for the rental. So since this is a linear system, we're going to come up with two linear equations that relate G and C. And we could call them equation 1 and equation 2, but since we have names, I'm just going to call them equation P for Pin Hall and equation B for Bloom Place. And so we know both of these equations are going to be in the form y equals mx plus b, because they're both rate and fixed price, So we're going to say that for Pin Hall, the cost is going to be the rate, which is, here we go, $15 per guest or per meal, same thing, plus the $500 fixed cost or starting point. At Bloom Place, it's $18 per meal, so the cost is $18 per guest or per meal, and plus $350. Okay, and so we're gonna we now have our linear system, and we're going to solve it. Now, of course, there's two different ways we can solve this algebraically. We could even solve it by graphing, plug these two equations into Desmos or to GeoGebra and see where the point of intersection is. But we have a choice algebraically between substitution and elimination, and both will work. But for me, whenever I see that I have, a variable equals and a variable equals, that means whenever I have a variable equals, that's, for me, that says substitution, sub one into the other. So I'm going to sub what C is for the first one into the second one. So I'm going to communicate well, and I'm going to say I'm going to sub equation P into equation B. And that means I'm going to sub 15G plus 500, where the C is in B. And then there we go, 18G plus 350. And solve, right? So subtract 18G from both sides, and I get 15g minus 18g equals 350 minus 500. So negative 3g equals, looks like negative 150. Divide both sides by negative 3, and I get that g equals 150, I guess. Negative divided by negative. So I found out that g equals 50. That's handy because now I can sub g equals 50 into either p or b. Why not for fun just doing b, and here we go. C equals 18 times 50 plus 350, and 18 times 50 is 900. So I have to write a therefore statement at the end. Maybe I'll get some room up here. Okay, and let's see. Maybe we need to actually first go back to the question, make sure we know exactly what we're answering. What did it ask? It says find the number of guests for which the charges are the same at both halls, right? And since we found the point of intersection, 50 guests costing $900, we found the answer to that. That's where they're both the same. And so we will fill in our therefore statement up here. Therefore, the cost will be the same. The question didn't ask, but I'm just going to mention that it was $900 for 50 guests. Okay, so two equations, both y equals mx plus b form, and then sub one into the other is easy, and make a nice therefore statement. Here we have a slightly different type of problem. I call this a number value type of problem. And you've seen actually this type of question before. It's the type of question where they give you some information about how many of something you have and what they're worth, right? So here's the $9 for CDs, what they're worth, DVDs are worth that much, and the total worth of both is $204. You also know how many you have. You have 20 altogether. Last year, you probably would have solved this with one variable, saying, well, I know I'm going to let C be the number of CDs and let 20 minus C be the number of DVDs. And you could still do it that way, but since we're doing linear systems, we're going to set this up with two variables. So we're going to let C be the number of CDs. I will not accept let C be CDs because there's difference, right? Maybe I don't know if you're not talking about how much they're worth or how much they weigh or how many they are. And of course, the other thing that I'm talking about, I'm going to let D be the number of DVDs. Okay, so we are, as it suggested, this is a number value problem, and that's going to be our two equations. Okay, we're going to have a first equation, which is going to deal with how many we have. Right? And we know we got 20 things. There it is. And we know that the CDs, the number of CDs plus the number of DVDs, the number of CDs, C, plus the number of DVDs adds up to 20. Very, very simple equation. The value is, well, we know that the total value equals $204. There it is. And it's $9 per CD. So if I took 9 times the number of CDs and I took 11 times the number of DVDs, that's what gives me 204. Okay, so now I have two equations, a number equation and a value equation. That's the second one. And I would suggest that number one is very easy to rearrange. Right? We could solve this again by elimination, but for me this is a substitution type because it's very, very easy just to change this to C equals 20 minus D. And whenever I can solve easily for a variable because it's nice and naked, has no coefficient in the front of it, then I go ahead and do that. And so I proceed by subbing sub 1 into 2. Away I go. 9 sub in 20 minus D plus 11D equals 204. 180 minus 9D plus 11D equals 204. collect my D's and I get 2D. I subtract 180 from both sides and I get 24. So divide both sides by 2 and I think I get that D equals 12. Right? And I'm going to then sub D equals 12. I have a choice between subbing it into 2 and subbing it into 1. I'm going to say the easier thing is to sub it into 1. I usually make a habit of subbing it not into my rearranged equation, but into my original equation. If I made a mistake rearranging my equation and I sub my answer back in there, I'm not going to catch my mistake. But if I sub it back into the original, then I might catch a mistake that I had made previously. Okay, so sub D, so C plus 12 equals 20, C equals 20 minus 12, C equals 8. So here let's double check how many CDs did Cody sell and how many DVDs did he sell. I think I can cover both of those with a single therefore statement, because I know right here how many D for DVDs and C for CDs. Therefore, Cody sold 8 CDs and 12 DVDs. Okay, so 2 types of word problems, 2 different kinds of setups, both that you've kind of seen before and are fairly simple to set up.